Day 21 about to begin. Managed to avoid snow today, unlike most of my friends. Okay, the monkeys are back. For example, each monkey is given a job, either yell a specific number or yell the result of a math operation. All the number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for two other monkeys to yell a number, and the nest troop monkeys might also be waiting for another monkey. Jobs to work out the number monkey named Root will yell before the monkeys figure it out themselves. Okay. Okay. Your situation will have lots more monkeys. How many more monkeys will it have? 2,163 monkeys. That doesn't seem like an excessive number of monkeys. So this looks like a fairly straightforward situation of we just need to prioritize the monkeys that have numbers and the monkeys that have answers. Probably the best way to do this would be, let's say we had, all right, let's do this. Actually, let's just do this. Well, let's not do that. I think what I want to do is, let's ignore this for a moment. Let's just look at what the answer is going to be. I think what I want to do is I want to have answers is going to be a dictionary of string to long. Problems is going to be a dictionary of string to kind of want yeah, okay. So let's say what I really want to do is I want to find all the monkeys that are waiting for data. I want to make it easy to look up the data that they're looking for. All right, so that when monkeys get answers, we know what things they're looking for, so we'll know when they're ready to be computed. So let's say we do string, string, string here, or actually really string, char string. Oh. How about object, char object? Waiting on is going to be a new dictionary. What if I do class unsolved? Public object. Right? Name. Object is going to be left-hand side. Object is going to be the right-hand side. The character is going to be the operator. We'll do it operation, so we don't have a reserved word there. Then we'll say long solve, public long solve. New not implemented. All right, so you're going to be unsolved, which means we're going to have a list of unsolveds. We're going to have a dictionary from string to unsolved as well. All right, so then we'll say for each for line and data, let's parse it. So pieces are going to be, pieces are going to be line, split on spaces. The name is going to be pieces sub 0, trim, end of the colon. Then we'll say if pieces is 2, then obviously we're going to put you in the answers. Answers add name long parse pieces sub 1. Otherwise, we're going to put you into problems. Unsolved is going to be a new unsolved. I think these are all going to be, I think I need a constructor here, right? Object, left-hand side, character operation, object. Well, this is going to be, these can be strings, as we know these are going to be strings, right? So this name is name, this LHS is LHS, this operation is operation, this RHS is RHS. Okay. So this is going to be the name, then this is going to be pieces of 2, pieces of 3 of 0, and pieces of 4. Okay, given that unsolved, we want you to go into the problems, right? The name, and then the unsolved, and then let's extract these. So this is LHS. RHS is pieces of 4. So you can be the right-hand side. Then we're going to do waiting on LHS unsolved. Waiting on RHS unsolved. Add. Okay. Actually, waiting on is going to be a list of unsolveds. Right, and then we're going to say If waiting on contains key for the left-hand side, then we do this. Waiting on LHS add. Actually, let's do this. Waiting on add left-hand side with a new list. We'll do the same thing with the right-hand side. So if not, waiting on contains key for the right-hand side. Waiting on add right-hand side. Then this is waiting on right-hand side add unsolved. Because obviously multiples of these things can be waiting on the same thing. And then once that's done, we're going to do for each var answer and answers. We're going to say record the answer. Answers key, answer key, answer value, right? Answers to list, because we're going to be iterating and our iteration might actually update everybody. So let's do that. Long value. I guess this would be name. If not, waiting on dot try get value of the name out var items return, right? So nobody was waiting on this answer, we don't care. We're going to do for each var item and items. We'll do this because we're going to remove things from that list. All right, so item, item left-hand side is equal to the name. Okay. What is your problem here? Possible unintended reference comparison. Cast the left-hand side type to a string is string. Jeez, I don't know why I had var there. Yeah, so that's okay. And we're basically going to say item left-hand side is now the value. If result is going to be item solve. If results not equal to null. So our index is, and this is the string name waiting on. Yeah, that's fine. So you're an unsolved. Are we actually going to need problems? don't think we are, but I'm going to keep it for the moment. So problems remove, item.name, answers add, item.name, and the result. Except we want to just record it. What we want to do here is we want to record the answer, right? And what's your problem here? Can I convert a long to a long? Yeah, that's because we need value. That's fine. And then we got to do the same thing for the right-hand side. All right. Okay, so that should run that whole list of answers. By the time we're done with that, we should be done, right? We should be able to say return answers of root. Theoretically, does, you know, if it compiled. Index is outside the bounds of the array, 28. One, two, three, four. You're either 2 or you're 4, right? All right, well. Did I do it wrong? Yeah, of course I did it wrong. 0, 1, 2, 3, hello? No. Yes, I did it wrong. 1, 3, 2. Input string dbpl was not in the correct format. dbpl. Oh no, that actually is 1. Sorry. Method or operation is not implemented, right? So we haven't done solve yet. I guess that makes sense, right? We have to write solve. All right. If, let's see, LHS is not long, LHS long, or right-hand side is not long, RHS long, return null, return operation switch. All right, so we've got plus, that means LHS long plus RHS long. And this is a lambda, not a colon. All right, so we've got minus times and divide, minus times and divide. We say long, but we don't know if there's ever a case where there's a modulus. This one worries me a little bit. Always integer math. All right, let's see what happens here. Root was not present in the dictionary. Okay. Let's get here. Let's see how we looked here. So we've got 8 answers. That all makes sense, right? So for each one of those answers, we're going to record answer key and answer value. And problems, we have 7 problems. And then the things we're waiting on 14 things. And apparently there's no dupes. That's fine. All right, so let's go here. So let's look at our locals. So DBPL is 5. Somebody should be waiting on DBPL, right? So this item is, I'm going to do something that can make my life just slightly easier. And also the name. Yeah, that's going to make my life easier. Okay. So the item is, yep. Okay, that's what I expected. Let's see when we get here. We don't need to stop there anymore. So our item is now 5 minus 3. Our result is 2. All right, so we remove the problems. Oh yeah, we forgot to do one thing here, which was items at name. No. Items remove item. Is that right? Yeah, that's right. Which is why we two-listed here, so we wouldn't have this problem. Okay. So here we've got a 5 minus 3. All right, so our problems go down. Our items are now empty. And now we're going to record the answer for PTDQ, which is 2. So there's LJGN coming through, giving us LGBD, CC, BP, SJ. So how come we never completed root? I would have expected us to complete root. All right, so let's set a breakpoint here. So isn't that interesting? We don't have any answers. Did I forget to record the answer in the answers list? I did. Wow. Oh no, it's right. Yeah, no, it's right here. Except that shouldn't be there. That should be here. And that's name and value. Actually, I don't want to do add because we might already be coming through with a value that we have already seen. So that's fine too. 152, is that our answer? That was our answer. All right, well, let's try it with our big data. First of all, see if it runs. All right, get a big number. And the run is fairly instant. I don't know why I came back here. Okay, part 2. Due to some kind of monkey elephant human mistranslation, you seem to have misunderstood a few key details. First, the wrong job for the monkey named root. Specifically, you got the wrong math operation. The correct operation for the monkey root should be equals, which means that it still listens for 2 numbers from the same 2 monkeys before, but now checks that the 2 numbers match. Now checks that the 2 numbers match. Second, you got the wrong monkey for the job starting with human. It isn't a monkey, it's you. Actually, you got the job wrong too. You need to figure out what number you need to yell so that the roots equality check passes. The number that appears after human in your input is now irrelevant. So that's kind of an interesting twist on this problem, isn't it? So one of the things we could do is we could just take human out of the list. Don't know which part of this I can share. So you need access to everything. Waiting on and problems. Actually, do you need access to answers? Yes, you do. So I can't really share any of this, right? Problems, answers, and waiting on. And then this is just always going to return null, which is fine. Problems, answers, waiting on, right? So we've got problems. I actually don't think we need problems. I just think we need waiting on. Answers and waiting on. We don't need problems. Answers and waiting on. So that still gives me all right, that still gives me 152. All right. So we didn't break that. So let's do this again. So this is going to be this. This is going to be operation. Name is equal to root. Your operation is now equals, otherwise it's that. And we're going to say this, which is if name is not equal to human. double quotes, please. So let's take a look at what we end up with at the end of this. Helps via debug. All right, so we obviously won't have root in the answers. Oops, that's the wrong one anyway. Okay, so we've only got 9 answers, which is fine. And then we're waiting on a bunch of things. I think what I want to do is also record answer is if items count is 0, then waiting on remove items, remove name, remove name, right? That way, we're waiting on 12 things. We're waiting on human, which makes sense. But more importantly, we don't have an answer for root. And if we find root is waiting for this, so we need to go find the one that says root is going to be this, and then we basically forward solve, I think. For this, we say PPPW must be 150, right? So then we're going to say let's go, we gotta go find the root is waiting on single name key is root. And we need to find the side that is not solved. Unsolved is, let's see, we do root LHS as string or root RHS as string or throw new invalid operation. So now we have the unsolved value. What's the problem here? This is a value, right? So what the problem is? Oh, yeah, except that doesn't work, right? We're not looking for things that are waiting on root. We're looking for what root is waiting on. Isn't there a version of contains that takes a lambda? Thought there was. Apparently not. So let's do this, where KVP value contains let's find the single, find the single element where the name is root. And that should also be a single. What is the problem? Select. Let's make sure that this is actually root. Because like I wrote enough link here that I feel like I screwed something up. Sequence contains more than one element. I guess now I do want problems. Fine. Okay, so I did get that. So this is root LHS or LHS, right? Let's see, unsolved name. Solved value is root LHS as long or root RHS as long, or throw new invalid. And you're going to tell me I can't use as with longs, of course. Okay, so root, we're looking for PPPW, and its solved value is now 150. We'll call you the solved name. That's fine. Okay, so now we have to sort of while true this, right? We need to we kind of want to record an answer here, right? Which is yeah, I think we should be able to do record answer. Answers waiting on the name is the solved name and the solved value. I think if we do that, answers should magically come up with something in human, right? Answers of human. Because we will have gone the opposite direction around. We did not get answers of human. So that's interesting. All right, so we know PPPW is 150, right? So if we record that answer, oh, I think we have to go backwards now, right? So now that we know PPPW, is there anybody waiting on PPPW? Actually, there might be, right? There should be. Except not root. Yeah, we don't actually care about that. No, so we need to do this, but we need to do it backwards. We need to record answer in reverse. Okay. So by knowing PPPW, that means we're going to, let's see what we should be doing here. By knowing PPPW, that means is we can go solve PPPW, probably. That's what we should be able to do, right? We should be able to solve PPPW as a result of that. So that means if I now go looking for waiting on, I don't think I need waiting on. I think what I want now is problems, because I want the PPPW problem, right? So if I go look at my problems now, I have PPPW, and I know what that is, right? Because that's going to be we knew that was 150, so we should be able to back solve this, all right? So I really want here, I want problems. I don't want waiting on. So where are my problems? Problems is this dictionary. Problems remove this name. No, we don't want to remove the name. We want to remove what just got solved. Actually, I don't really care about cleaning up problems. I just need to look up problems. Now I want new problem is problems of the name. New result is going to be equal to new problem dot solve reverse. Think. So I'm going to solve this in reverse. Long, solve reverse, long answer. What are you going to give me back? You're going to give me back the next set of things to get recorded, right? Which would be a string and a long. Right, so we're going to do this. name is LHS as string or RHS as string or throw new invalid operation. And then we've got other side is why do we have two solve reverses? It's fine. So the other side is we're going to steal this nonsense. Except we have to know which side it is, right? Yeah, so let's do this. So if LHS is string unknown, else this, right? So then RHS long is RHS, let's see, how about this? If RHS is not long, RHS long, throw new invalid operation exception. Okay, so knowing that I'm solving for the left-hand side, so I've got, so this is the case of answer equals unknown times known. Unknown operation known, right? So returns operation switch. If you're an add, right, then that's I'm going to have to write these down just because I don't. Answer is unknown plus known. So therefore, unknown is, if we subtract an unknown from each side, we get negative unknown plus answer is known. And then we get negative unknown equals known minus answer, which means unknown is equal to answer minus known. Okay, like, remember I said I'm not good at math? That's what I have to write it all down. What do you want from me? All right, so you're going to return the unknown, and you're going to return answer minus the right-hand side of long, right? And then, of course, this is throw new invalid operation exception. All right, and you're a lambda. Thank you. So that means for this, so this is answer is unknown minus known, which means, actually I could have done this much easier, right? Which means I could have done answer minus known equals unknown. That's what I could have done. And so this one is unknown is answer plus known, right? So unknown answer plus right-hand side long. And then multiplication. All right, so answer is unknown times known. That means unknown is answer divided by known. All right, so this is unknown answer divided by known, right side long. Which means this is the exact same except multiply. Right? Okay, then we go the other way. you're just going to be known. So you should be left-hand side. And then unknown if right-hand side is not string unknown, we also throw. You don't want me to reuse that, huh? Unknown. Fine, we'll just do this and let the cast fail. Same up here, right? So you're the left-hand side, turn operation switch. So if this is, answer is known plus unknown, I guess because that's fine. Answer is known plus or minus unknown. So to get unknown, we subtract it from both sides, which puts us with answer, or we add it to both sides, right? Answer plus unknown is known, and then unknown is known minus answer. Really? Now I deleted all those up there, which maybe I shouldn't have done. Because if this is known plus unknown, then what we do is we subtract known from either side, which makes answer plus known equals unknown. We subtract known from each side, sorry. So that's answer minus known, that's known minus answer. Okay, answer is known times unknown. We divide known by both sides, so answer minus known, divided by known is unknown. So this is answer divided by known. Again, it's exactly the same, which I guess isn't too much of a surprise, because what do they call that? Associative. So if this is known divided by unknown, then in order to get unknown on both sides, we need to multiply by known. So this is answer times, multiply by unknown times known, which then we divide by answer. That makes unknown is known divided by answer. Known divided by answer. Okay, we've been doing this all in the debugger, because of course we have. So we've got record in reverse. Let's, actually void is fine. Let's just run this once and make sure that we get the right thing in reverse. Okay, so what we know is PPW is 150. That's what we know. So we put that in the answers list. We grab the new problem, which is going to be PPPW, right? And then we're going to solve in reverse with a value of 150. All right, so let's go in here and we'll say left-hand side. So left-hand side is the unknown. So unknown is CCZH. The known is 4. So we should have 150 is something divided by 4. So it's going to be 150 divided by 4, right? No, 150 times 4 should end up with 600. Answer times known should be 600. Okay. So we did that once correctly. That's good. We're going to do long. We're going to say while true. We're just going to call you problem. We're going to call you result. If result, item 1, sure, but let's give them better names. Name and value, right? So we're going to say if result name is human, then we're going to return result value because we're done. Otherwise, we're going to say the name is result name now, and the value is result value, and go back and do it again, right? Okay. So this will give us CCZH of 600. So we go grab CCZH, and that's 4 plus LGVD, which gives us 596. And then that gives us LGVD as our problem, which is 2 times something, 596. We're going to divide that by 2 is my guess, right? Our result is now 298. All right, this all looks okay to me. This is going to return record answer reverse, all right, because that's going to give us our human value back. So 301 is what they say. Okay, let's see what happens. Another fairly substantial number that I have relatively high confidence in. Actually, yeah, you had to hit them. Yes, I know. There we go. Okay. Again, not too bad. About an hour, just like yesterday. As I had hoped, things are, I think, kind of sliding down the backside of the super difficult problems, which is good because my brain is so completely done with 5-hour coding sessions for these things. Like, whatever. All right. Yesterday I cleaned up the code on stream. Today I don't think I'm going to do that. I think I'm done. I think I might come clean the code up later. Yeah, I think that's it. So I guess I'll see you all tomorrow.